Hello, Professor Kien and friends. Now I would like to talk about my final project for the course, Design a Simple Three-Note Arpeggiator. So what is an arpeggiator? An arpeggiator is a digital musical instrument that is used to make arpeggio. When you press a chord, which is a combination of notes, onto an arpeggiator, it will produce an output that is a looping pattern with each of those notes played one at a time. So to give you an example, I have this recording. So normally if you play more than two notes at the same time on a traditional acoustic instrument, for example, piano or guitar, the output is always the combination of those notes, right? You can't really hear each note separately. For example, but when the chords are arpeggiated, that means each note within it is split, and you can hear each individual note one at a time here. So that's what made electrical music cool and interesting because of this sound effect. It creates like a wobbling effect that make you want to move and dance along with. So as someone who loves electrical music, I'm always curious on how engineers design digital instruments and create those sound effects. So in this project, I designed a simulation of a arpeggiator, but way simpler than the actual arpeggiator. I have 4 keys, but my rule is you can only press 3 keys at the same time. If less than 3 or more than 3, no sound will be produced. You turn on the arpeggiator by press this button, and after you press a valid combination, which is 3 notes at the same time, then the output will be out in the speaker. So step 2, I define inputs, outputs, and states. I have 3 inputs, A, B, C. A is the indicator. When A is 0 to 1, that means 3 notes are pressed. A is equal to 0, that means it's an invalid combination, then no sound is made. BC is the encoding of the possible notes combinations. Suppose the 4 notes are note 1, 2, and note 3, note 4. I have this encoding scheme. If the note combination is 1, 2, 3, then the encoding would be 1, 0, 0. Note combination 1, 2, 4, then encoding 1, 0, 1, 1, 3, 4, then 1, 1, 0, 2, 3, 4, 1, 1, 1. And when no sound is made, that means 0, 0, 0. And for this, I only care about A. I don't care about BC because when A is 0, no matter what BC is, it will never play any sound. So the output I will indicate by the LED on circuit verge. I have Q1, which means note 1 is played. Q2, note 2 is played. Q3, note 3 is played. Q4, note 4 is played. I have 5 states. The first state is S1, 0, 0, 0, means no note combination is played. S1, 0, 0, 1, note 1 is played. S2, 0, 1, 0, note 2 is played. S3, 0, 1, 1, note 3 is played. S4, 1, 0, 0 means note 4 is played. So from that, I have this state transition diagram. So I will first begin from S0, 0, 0, 0, no note combination is played, right? So no sound. I don't care about BC. I only care about A. So when A is 0, it go back to the original state, no sound. To shift from no sound to the S1, which means the first note is played, then it goes through 3 combinations. 1, 2, 3, encoding with 1, 0, 0, note combination 1, 2, 4, encoding with 1, 0, 1, 1, 3, 4, encode with 1, 1, 0. Then to make state 1 move to state 2, then I will have to go through the combination 1, 0, 0 and 1, 0, 1. State 2 to go to state 3, I need to go through the note combination 1, 2, 3 and 2, 3, 4. And for state 3 to state 4, I need to play the note combination 1, 3, 4 and 2, 3, 4. For state 4, to go back to no sound, basically I play this 3 note combination 1, 2, 4, 1, 3, 4, 2, 3, 4. And for state 0, which means from no sound to note 2, I'll play the combination 2, 3, 4, which is encoded with 1, 1, 1. For state 3, to go back to no state, I play combination 1, 2, 3, which is 1, 0, 0. The color indicates a complete cycle. For example, if I play the note combination 1, 2, 3, I basically start from no sound to sound 1, and then sound 2, sound 3, and finish. Or if I play, let's just say I play note combination 2, 3, 4, I begin from no sound to sound 2, and then sound 3, sound 4, and then go back to no sound. Yeah. And from that, I have this truth table. That's 17 rows. From that, I use sum of products. I got the logic expression for the state transition. Then I move to step 6 and step 7, which is writing truth table for outputs and logical expression. So for the current state, when it's 0, 0, 0, that means no output is produced. When the current state is 0, 0, 1, that means the first note is played. So the first note is 1 and the rest is 0. When the current state is 0, 1, 0, that means the second note is played. When the current state is 0, 1, 1, the third note is played. 1, 0, 0, the fourth note is played. And then I have this logical expression. Step A. Now I implement the circuit on circuit verge. First, I begin by drawing a master-slave flip-flop. And then I insert these 3 master-slave flip-flop here. Since my current state, I use 3 bits. That means I need 3 master-slave flip-flops. I have 3 inputs, A, B, C, which indicates the note combination. And I have this logical expression for the next state. And on my right side here is the current state. And then I have this logical expression for the outputs, Q1, Q2, Q3, and Q4. So I also have this clock. So let's try. Let's say whatever BC is. Now, if A is 0, that means, you see, no LED is lights on, no sound is produced. If I have A is equal to 1 and B is equal to 0, C is equal to 0, then I have this output. Note 1, note 2, note 3 is played. Let's try 1, 0, 1 combination. Then that means note 1, note 2, and note 4 is played. Now if I try 1, 1, 0, then you see it's 1, 3, 4. Note 1, 3, 4 is played. And if the combination is 1, 1, 1, let's say, then we have 2, 3, 4 is played. This simulation is exactly what I expect my Arpeggiator to do. Yeah, so that's it about my project. Thank you for listening to the end. I especially thanks Kien for his guidance, because you know what, like the Arpeggiator in real life has many combinations, many notes, like 12 notes. So at first I had difficulty trying to figure out the note combination, but Kien helped me a lot. And if I have more time, I would definitely dive into how to implement more note combination and how to create pattern for the notes. For example, the upward, downward, or random pattern to make it sound like the Arpeggiator in real life. Thank you.